Hi folks, welcome back to Math 2. This is Unit 6, Lesson 6.3, Activity 2. We are on the last question, number 3 for Activity 2. Suppose you have a circle with center h, k and radius r. Write an equation that would allow you to test whether a particular point xy is on the circle. So I've drawn a little visual below here to help us better understand this question. We are actually going to generalize the process that we've been doing in Activity 2 even further now for any center point with coordinates hk and any particular point on the circle xy. We can still subtract the y coordinates of this point and the center point to find our vertical distance, as well as the x coordinates to find the side length of our horizontal distance. So let's take a look over here. I'm going to label this side in our brown. So this is going to be relating to the a squared part of our Pythagorean theorem. So our y coordinate here is y, and then our y coordinate in our center is k. So this distance I'm going to write as y minus k. And remember, right, this is pretty much the same process as before where we're subtracting the y coordinates to find the vertical distance. For my horizontal distance, I am going to subtract my x coordinates. So I have x minus h. And then lastly, right, we are also not even given our radius. And so here we're just asked to use r to represent our radius. And remember that our radius in this scenario is always going to be our hypotenuse when we draw that line connecting the center and a particular point. So I'm going to label this as r for radius. All right, so now let's go ahead and plug in our values. So we know that y minus k can be our a value, and then x minus h can be our b value here. So wherever I say CA, I'm going to plug in y minus k. So we have y minus k, the whole squared, the whole thing squared, plus we know x minus h is our b value here, so x minus h, the whole thing squared, equals, and in this case, right, our c is our unknown radius, which is our r. So I'm going to just say r squared. Great. So we have actually just come up with an equation for our circle. So this equation would work for any center point h comma k, particular point x, y, and then radius r. And you may sometimes see the equation written like this. So x minus h, the whole thing squared, plus y minus k, the whole thing squared, equals r squared. Right, the only thing that really happened between these two equations here is that the order of the expressions was flipped. They still mean the same thing. They'll still help you get to the end result. So I'm just going to say same equation. All right, great. So now we've gotten an equation that will allow us to test whether any point xy is on the circle with center hk and radius r.